Determine the force in member AE, BE, and BC of the truss and indicate if the members are in tension or compression. To solve this problem, we're going to use method of sections. Let's begin by finding the external reaction forces of this truss. So we're going to have one at the roller and another one at pin connection C. We're going to take moment about the point C. We're going to have clockwise By, and it's 8 feet away. Then we have counterclockwise 8K, and it's 8 feet away. We have clockwise 6K, 6 feet away. And we have counterclockwise 12K, 16 feet away from point C. All equals to 0. Solving for By reaction, we get our solution as 27.5K. Now we can sum the forces in y direction to solve for Cy. Or we don't really have to solve this, because what we're going to do is we're going to cut this member through AE, BE, and BC. And we're going to use leftmost side of this truss, which means this area. Therefore, we don't really need Cy, but it's super simple to solve if anybody needs to. Now let's draw the free body diagram of our leftmost side. We're going to have member AB. At A, we have external reaction force of 12K. At B, we have external reaction of 27.5K. Then we're going to have reaction from force BC. We're going to have force reaction from member AE. And lastly, we're going to have another one from member AB. To solve this, first of all, because we don't consider any of the other points of this truss, we're going to have imaginary point E, where we're going to take the moment. In doing so, it will help us determine our force member BC. So we're going to have counterclockwise 12K, and it's 8 feet away. And then we're going to have clockwise force BC, 6 feet away from E, all equals to 0. Solving for BC, we get our solution as 16K, and this member is going to be in compression. Now we can sum the forces in X direction to find our solution for member AE. So we're going to have horizontal component of member AE, which is simply going to be AE times our horizontal component. To find our horizontal component, we need to find the length of member AE, which is simply going to be, using Pythagoras theorem, 8 squared plus 6 squared. Solving this, we get 10 feet as our solution. Therefore, it's going to be 8 by 10. And then we're going to have negative force BC, which is 16K, all equals to 0. And finally, we get our solution for A as 20K. And this member is in tension. Now we can sum the forces in y direction to find our solution for our final member, EB. So it's going to be negative 12K, positive 27.5K, negative EB, and positive horizontal or vertical component of force A, all equals to 0. In this equilibrium equation, we get our solution as 27.5K, and this member is in compression. So on this, we get our final solution for all three required members.